Okay, 1 minute past 10 o'clock in Lithuania. I'm still admitting people. However, I should start webinar, and today we are going to talk about digital transformation for biomass boilers and how to unlock effectiveness. General rules for the webinar would be because due to many participants, we won't have much time to allow you directly to talk maybe at the end. However, you can chat your questions anytime, and I would try to answer these questions. So for today, we are going to talk about who is energy advice, digitalization maturity, what is the digital twin, what is the digitalization, why digitalization, how beneficial digital twin, fire site erosion and corrosion of boilers shortly, and how a digitalization could help. What is the best digital transformation scenario for biomass boiler? How to reduce boiler maintenance costs, human errors that can be avoided, what KPI should be followed in order to increase boiler efficiency, how to know if your company is ready for digital transformation. So these questions we would try discuss in 1 hour, in fact. And 1.5 hours we would spend for the discussion and a question session. So what is Energy Advice? Energy Advice is a technology and consulting company focused on energy-intensive industries and creating digital tools and providing consulting services to increase efficiency and sustainability. So what is the digitalization? First of all, digitalization is the transformation of a client or of a customer. We remember well mobile phone 20 years ago development, 10 years ago smartphone development. We are using in our daily life a lot of smartphone application and etc. And somehow we create for us or good feeling or allow us to do job easier. However, in the industry we have a lot of data, and in fact today data is available in the company inside, and what to do with this huge amount of data. It's called big data. And so because digitalization is transformation of a customer should be ready for this transformation and should be ready mental to change the way how he is thinking. So also digitalization creates opportunity for us to create some tools, for example, digital worker or maintenance insight tools or energy insight tools or digital twin, and finally maybe to do some operational optimization in general. Why digitalization for biomass boiler? Because people are telling that we have a need to access data from anywhere, maybe from home, maybe from their office, and not to go to the boiler house. Some data is missing, data blind spots because of expensive metering. For example, if we are willing to measure flue gas flow or air flow, we need flow meters. However, flow meters in general suffers from environment, and because we suffer from environment, the measurement error probably is unacceptable during the lifetime, and we need to recalibrate metering devices. So some data is missing in general, and we need somehow to understand the process inside and but we have another data which could be involved indirectly to calculate this missing data. And already a lot of data available, however, still do not create value. We remember the industry-free philosophy where we need to put everywhere meters. We need monitoring system. We need to collect data. And now today we have what we have. We have a lot of data. Everything is in the database probably. And what to do next? So the data still do not create a value. So our goal is to create a value using this data. So digitalization maturity in general, if we're coming back, I still admitting people, sorry. We have microcontrollers, which control process according to the set points. And of course, we have some SCADA visualization. And human can do impact to the process through changing SCADA set points. It's general, so digitalization maturity could be at the level 1. Next is we added some extra metering devices. For example, fuel wave in biomass boilers, for example, electricity meter, heat meter, okay? So we have meters here. Okay, if this is not enough, we can add multi-variable control, and in fact, we do not have human impact on the control. It could be third maturity level. Finally, we added monitoring system, which monitor everything. Take the data from the SCADA. We added maybe extra metering devices and put everything to the cloud. So we have monitoring system, but what to do with data? And the fifth level is digital twin. Digital twin, we will talk shortly about digital twin in next couple of slides. However, we have pyramids, and here we have data analysis. Okay, here we have process control, we have collection of the data, and here we have activities with data, and probably these activities would be automated. So what is the value? How to calculate value of these activities? If you put the microcontrollers and SCADA system, control system, return on investment would be probably due to fuel saving and hardware maintenance savings. If we put extra meters, the return on investment could be calculated because of better control of electricity consumption, better control of fuel consumption, maintenance decisions. If we put multi-variable control, probably we could reduce cost of human and probably save another amount of money on fuel consumption and hardware, I mean lifetime. If we put monitoring system, probably we would save only cost of human for the maintenance. People are not going and not saving with time for the collecting data. And the digital twin probably would provide you advanced boiler control, extra efficiency, fuel accounting, fuel quality evaluation, prolonged time between maintenance and predictive maintenance. So finally, with digital twin, we involve all data we have. We don't change control system, we don't change monitoring system, we don't change, we add data analytics called through digital twin, and with data analytic allow us to get some extra efficiency, so we have extra return on investment. What's next? So digital twin, what does it mean? It is a collection of digital data and model representing physical object. A collection of digital data, it is just a monitoring system. But if we put models, it could be stochastic models or could be physical system models, and these models represent physical object, it would be digital twin. On other hand, in other words, it is a digital copy of a physical system to perform real-time optimization. Copy of a system to perform real-time optimization. And also it could be like a real-time digital replica of a physical device. In other words, it's model which allow you to perform real-time optimization. I put a couple tables to compare the capabilities. For example, we have control system and we have digital twin solution. So parameter, actual air supply. In fact, in control system is not available except we put extra metering device. However, digital twin allow us to calculate amount of air was supplied to a furnace, if you're talking about the boiler. So in fact, it's indirectly we can calculate air supplied. And even though if we have installed meter device, we can check measurement error, detect error, or what is the error between the measurement and calculated value. It's like a calibration or monitoring of precision. We can calculate required air supply for the boiler, for the burning process. In fact, in control system is not available and probably is not possible because we need to put mathematics describing burning process, but in digital twin we definitely have. Amount of fuel already burned per kilogram per second, for example, or kilogram per hour. And in fact, in control system is not available, but possible if we put measurement device, some measurement device, kilogram per second is going to the furnace probably, but digital twin by itself already have, and if you can measure with, you can detect error with a digital twin or measurement error. Required fuel supply is interesting because fuel humidity is changing, and through that time, and at 1 hour you can have fuel, for example, 40% of water content, on another hour you can have 35 or 45% of water. And in fact, require fuel calorific value are changed. So we need to understand what is required fuel to supply each second, each minute. In fact, in control system is not available because control system fuel supply control according to another variables like a flame temperature, flue gas temperature, and etc. Heat consumption, steam consumption, output. But digital twin can evaluate required fuel supply. Another flue gas maximum temperature in furnace. In fact, this control system knows this because have thermocouple or pyrometer measurement devices. But in our expertise, the pyrometer or thermocouple could be installed in bad place, and if flue gas temperature in the furnace could be higher or lower than the measured value. So digital twin allow us to calculate and detect error of a measurement. Fuel calorific value, absolutely impossible to in the control system. I mean, for the which biomass boilers. But digital twin allows to do this. Energy balance automatically each 5 minutes, probably not available because water side yes, but flue gas side or fuel side no. Heat load forecast probably no. Metering device error evaluation probably no. However, digital twin can. And we can put here a lot of other points or data which blind spots, yeah, what we cannot measure, or we should control error of a measurement. For example, oxygen level. Oxygen in flue gas meters day by day, hour by hour, need to be cleaned because the measurement error increase, and digital twin understand that the measurement error increase. However, control system, according to this oxygen level, control air supply to the furnace, so error increase make impact to the control system measurement error and decision of a control system. And we can put other variables we should monitor. And when we are talking with a client, sometimes clients are asking us how you do this. And one question I received from Alexander, required fuel supply, you need to know moisture content or calorific value. Yes, and people asking how you are doing, but I raise question in different way, not how we are doing, but what do you need in addition to do what is your requirements, how we can help you. So required fuel supply, yes, it's according to the moisture content, and we need to evaluate calorific value of a fuel which is inside the furnace, and this is possible through digital twin. Mr. Yanis asked me question how the calculation of fuel calorific value are done and what data the system should get calculation correctly. Yes, we need all SCADA data. Because we describe in digital twin, we describe boiler as a set of equations. What is the number? Maybe 300 equations which describe boilers, and we are solved at the same time, and we can correctly understand what is the fuel calorific value, what is water content, and how much fuel we should push to the furnace to produce heat according to heat requirements, according to heat demand, or steam, or water demand. So case study, digital twin case study, measure parameters indirectly. Issue, there is no flue gas heat consumption meter. We have the client which do not have heat consumption meter because the heat consumption consume flue gas. With heat exchanger, and heat exchanger produce steam. So the flue gas flow meter installed. We bought flue gas flow meter. However, we found that dynamic this flow meter do not due to measurement technology inside is not sensitive to the flue gas flow dynamics. So what to do? So the scheme is like this. It's flue gas from a furnace. It's temperature 973. In this color is real measurement, measured data, collected each second, calculation each 5 minutes, and it's called Dropbox, which in fact. We have here mixture of the flue gas. Flue gas go to the heat exchanger. It's a fan which creates a flow, and this is a return flow, and it's flow output to the another part of a boiler. So the question is how to calculate flow here, how to calculate flow from the furnace, how to calculate what is the heat consumption here, and what is the heat consumption here. It's a very easy question, but we have measurements of temperature. We have measurements temperature. Okay, we can see here probably is bad data, and we detect this bad data. Here we have temperature output. We have fan, characteristic of a fan. We have variable frequency drive installed here, and the variable frequency drive set point from 100%, it's 50 Hertz or 60 Hertz, I don't remember well, but it's percentage from the nominal of a Hertz. And this is kilowatt electric power, and this is pressure difference before and after of a fan. And we calculate from a characteristic efficiency and flow. Evaluating the density of a flue gas, we understand what is the mass of flue gas. We calculate recirculation, flow, and consumption from the furnace. So we understand the heat consumption on the heat exchanger, and we understand the heat consumption on the total for this unit. So these values are calculated each 5 minutes. So solution is variable frequency drive, electric power, fan characteristic, pressure difference, and available. So if it's all this data is available, so we can evaluate the flow, mass flow, and we can calculate heat consumption in this scheme. So digital twin allow us indirectly to analyze the flow from the furnace, flue gas flow from the furnace, for example. It's case study. And no additional flow meters, in fact, is required. And we found that this flow meter, which is installed here on the lower temperature side to 260 degrees, is quite special flow meter at these high temperatures. The calibration was done bad. That's it. So everything was fixed. Next, corrosion effects. One of the most important and critical for the boilers is corrosion and erosion process. And corrosion and erosion process are slightly different. Sometimes people just are telling that it's corrosion, erosion, it's a problem, and we have a problem. But in fact, we should separate these questions because we are different. And we should understand that corrosion is gradual destruction of materials by chemical or electrochemical reaction. But erosion is a process in which material are removed from the solid surface by action of the solid particles. Actions, I mean mechanical action impinging on it. So if the corrosion is electrochemical or chemical process, so erosion is mechanical process. And okay, corrosion effect, we have quite a lot: pitting weld, high temperature, fuel ash covered tubes at a high temperature. However, we should understand a couple of things: what we can do and what we cannot do. If we have fuel and fuel consists chloride and sulfur inside and other alkalines, in fact, we cannot change the fuel at the moment when we burn the fuel. At that moment, when the fuel is burning, the fuel cannot be changed. Later, after analysis, we can change supplier of a fuel because maybe this supplier fuel is some with high chloride or sulfur. We can do this, but during the period when the fuel is burning, during these seconds, minutes, we cannot change content of fuel. But what we can do, we can in fact control flame temperature, flue gas temperature, and why it's important, because I put it here a couple examples which probably not right examples for the right case, but for the idea to represent that the corrosion rate in fact depends on the content of a steel, chromium and nickel, yeah, probably, but a composition of a steel. But if you look to the corrosion rate, centimeters per year, this highly depends on the fixed, for example, content of the nickel. It increases exponentially increasing temperature. So we have a boiler design temperature and we have real temperature, and in fact, controlling the temperature, we can control corrosion rate. So it's for the corrosion effect. And for the erosion effect, erosion depends on particle size and flue gas velocity. And these parameters are controllable, in fact. through the burning process. If you control burning process, we can control these parameters. However, another part of erosion reason is like a collision angle or surface hardness. It's probably uncontrollable during the burning process, so we cannot impact it. But fuel content cannot be controlled. However, flue gas temperature or burning process could be controlled, and this would make impact on the corrosion rate of your furnace. So erosion and corrosion, in fact, we can understand wall thickness, reduction rate, and operating hours. Probably we have a characteristic for each boiler. And if you are looking for the reasons of a corrosion and how these reasons statistically, so long-term high temperature and cracking, short time temperature creeping, it's 30%, 40% reasons. Okay, ash corrosion probably would be related on the ash, and erosion could be commonly fatigue and hydrogen damage. So almost half of reason of or even higher percentage of reason would depend on the burning process. Dew point corrosion. It's another type of corrosion. Of course, we have control issues. Boiler exit can lead to issue with dew point corrosion. It's called dew point corrosion, and dew point temperature depends on the moisture content in the flue gas. And if a gas exit temperature is not managed properly, the rapid corrosion occur and necessitating stage replacement. So in fact, what we do in our solution, we calculate dew point temperature of a flue gas at each 5 minutes, like a digital twin, the same. Forecast. Of course, if we have flow consumption data, we can always make the forecast of what would be heat consumption. And this solution is, this example is from the industrial company, where the boiler installed to the industrial company, where the random process very active. I mean, heat consumption could stop rapidly and increase rapidly. And it's quite not stable process in the industrial company. However, we can forecast heat consumption quite well. For the utility which produce heat for the district heating company, it's probably easier task and could be done with less error. But why we need heat energy production forecast? Because we have better control of fuel supply, avoid surplus fuel, just simple, we not push surplus fuel to the furnace, better control fuel burning, of course, because of limitation of a surplus fuel and limit temperature flue gas fluctuation. Sorry, sun is shining. So it is general about the digital twin capabilities, and Energy Advice produce a SaaS cloud solution, and we adopted this solution for the boiler solution. It's called a SaaS boiler, which provide you data analytics in real time. And how architecture inside looks like, we have a SaaS cloud. It's installed in our server-side cloud solution. However, we put to your client side, to your physical server, data collector software, which collect data, for example, from your controller PCU, for example, Siemens, Wonderware, InTouch, or whatever controllers you have inside, or SCADA system inside. We can collect data directly from the controllers, or if your SCADA system, control system already have database, if you have analyzers or any smart meters, we collect data also. And probably we should write here also that if your data already is in a cloud, we can with REST API take the data from your cloud and provide the digital twin solution for the biomass boiler. So general structure, what is available, and how we perform. Inside the SaaS cloud, I show you a short print screen. Late at the end of the presentation, probably I would connect directly to the, some project and show how it look like in project inside. So we have some schedule task tree, we have dashboards, we have data section where you can analyze by yourself data, dashboard, you can see some resulting things, and we have Python inside where we run digital twin on Python. However, you can add, if you have in your company inside data analytic people, these people can add Python code and run Python code in parallel. For example, this is our code, but you can run in parallel your code. And you can put your data, which is input data, which is output data, Python, how often it should be run, minute calculation range, 5-minute calculation range, hourly calculation range, or daily, weekly, monthly. In fact, you can access through web. You can monitor biomass calorific value, efficiency, moisture content, also its impact on efficiency, individual boiler components. It's all results described in tables and graphs, and access it through your company account to sas.energyadvice.lt. We can, of course, provide you optimum control task set points. You can access unlimited historical data, PDF reporting, biomass accounting. Also, you get emails with the reporting. Here's an example of a dashboard where you can push in the dashboard different results, different analytics results. So what parameters could be optimized? If we come back to a digital twin solution, in fact, digital twin allow us optimize involving all parameters of a boiler. It's multi-variable, all variable optimization of your operation. And the question, what parameters we can optimize? The answer is that, in fact, all parameters which control system control. If a control system control amount of fuel supply, yeah, it's control. So we can impact to the set point how our control system operate. If a control system control amount of primary air supply, so we can make impact to the set points of a control system which control amount of primary air. Secondary air, generally it is related to oxygen level measurement. However, how we make impact on this, we simply we understand that the fuel is burned fully and perfectly. And the oxygen meter is metering well or not well. What is a metering error? If we have furnace with a grate, so it's we can make impact on movement. And if you have flue gas recirculation, for example, we can make impact to the recirculation. Next, flue gas temperature and temperature at furnace boiler is operational status indicator. Amount of oxygen is related to amount of air supply to a furnace, although part of oxygen is emitted with biomass fuel. So don't make mistake on oxygen level and air supply level, because fuel content fuel consists of oxygen inside, and part of oxygen is coming from a fuel. Surplus supply air to furnace, increased temperature at furnace, and amount of oxygen in flue gas. It's general, so fuel surplus reduce boiler efficiency in general. So what we see in the boiler dynamic, when we push more fuel, if we push it more fuel at that time, when is needed, when is required, what we have, we need to burn this fuel, and this make the impact on the reduced efficiency. And what does it mean? Efficiency? Efficiency is division of two numbers. One number, it's like a KPI. It's produced heat divided by burned fuel in megawatt hour or calories, for example, or joules. So, and if we burn surplus fuel, in fact, this would decrease our lifetime general. And lifetime is evaluated by produced heat and combusted fuel, increased efficiency, prolonged time period between maintenance. It's general rule. Okay, coming back to bath tube curve. You remember from the university time that failure rate high at the start, operating start of a boiler. During operation, probably failure rate could be lower, and failure rate increase at the end of operation time. So, in fact, our decision to do maintenance or to replace something or to do some maintenance activities could be too early or too late. Too late, it's not good because we stop boiler. Too early, it costs. So in fact, we balance in between here. So if we move this curve to the right, it increase risks, but save money, probably due to maintenance, but increase risk and probably it could cost. If we do it earlier, this also it costs. So black dotted line denotes usual equipment replacement time of equipment from initial failure or after maintenance. If a boiler is operating, for example, 2, 3, 4, 5 years, the actual replacement time should be red dot line probably. Customer has replaced equipment too early, and through digital twin, customer would know that no need to replace equipment at the black dotted line. Okay, and customer would plan equipment replacement at yellow dotted line, which has utilized the equipment to its maximum potential. So through this, we can save part money for the maintenance. Predictive maintenance, in general, it is a technique designed to help determine a condition of in-service equipment in order to estimate when maintenance should be performed. This approach promises cost savings over routine or time-based preventive maintenance. Because tasks are performed only when warranted. It's regarded as a condition-based maintenance carried out as suggested by estimation of degradation of a state. So the main promise of predictive maintenance is to allow convenient scheduling or of a corrective maintenance and to prevent unexpected equipment failures. Predictive maintenance differs from preventive maintenance because it relies on actual condition of equipment rather than average of expected life statistics. And some of the main components that are necessary for implementing predictive maintenance are data collection, processing, and fault detection. So probably data collection you already have, and pre-processing is what deep pre-processing we need. And probably it's digital twin, because usually we have a big amount of data, but we cannot make a right decision. So we need pre-processing, and digital twin is on the right way. So we increase time to failure, and because we have prediction and we have shadowing and resource optimization in general. So predictive maintenance, we can separate to the separate components of a boiler which make impact to the boiler operation. For example, oxygen of a flue gas level. You remember, if the oxygen measurement is bad, so we have or CO emission or surplus oxygen and maybe better burning, but with losses. Furnace flame temperature. Do we know, is this right temperature? What we see through a metering device? It's an interesting question, and probably not always. the temperature we measure is the right temperature, what is exactly in the furnace. Ventilator effectiveness, water supply pump effectiveness, water supply regulator performance, frequency converter performance. In fact, we need to collect data from the VFD. Heat exchanger quality, water supply flow meter error. Okay, metering error. We should understand what is the metering error, because flow meters also could make errors. Steam flow metering error and bad sensor detection in general. So all these things could be done through digital twin and would help us to understand boiler performance. Example for the flame temperature. This is example from real study. It's like a case study where we see the temperature. Blue is monitored, metered temperature, and red is calculated temperature. We understand that correlation quite good. Yeah. But what does it mean that we do not measure temperature at some spots where temperature in fact is calculated is higher than the measured value? Next, we can understand through the data analysis what is the distribution of a temperature. And for example, in this example, 46% of the time, the temperature was between 1000 and 1050. 23% was temperature between 950 and 1000, and 3% of time, temperature was higher than 1100 in this furnace. Okay, so flame temperature evaluation of by itself, and for the corrosion effect, and for the corrosion rate, and for the bad sensor data detection is important. Expected operation time. When we monitor efficiency of a boiler each 5 minutes, we understand the influence of the water content or calorific value of the fuel to the efficiency. We understand efficiency dependence on loading of a boiler. For example, lower efficiency at the higher demand, heat demand, and for example, higher efficiency at the lower demand. However, knowing this data, we can forecast decrease of efficiency. So when we can forecast decrease of efficiency, you can understand that somewhere here it won't be acceptable level of efficiency, and you should do maintenance activities. It's efficiency decrease, but on other hand, another important, on this axis, it's biomass control error. I mean, digital twin calculate what is the optimum set point of the biomass boiler for the control system. And we can calculate error in percentage from the real set point, and we can understand the efficiency. What is the real efficiency? And we see that in fact, efficiency distributed. If the error increase, efficiency decrease. If error increase, efficiency decrease. And in fact, the boiler, if we calculate monthly average, because usually if a bad fuel accounting, we can compare data maybe week range or maybe monthly range. So we can make decision that our boiler efficiency average, maybe it's 80%. Yeah, but it would be our decision. A boiler is 80% efficiency. It's good or bad. Maybe we need to do maintenance. Yeah, but in fact, our boiler operates at 85, maybe 86, but do not operate at 80. Probably here would be 87 up to 92. 92, it's maximum theoretical by manufacturer declared data. So But because we run boiler not in the optimum point, it's fuel supply control error. Because we won't do this in the optimum way, our decision is here 80%, but in fact our boiler is at 80, probably 5% because it can reach this load. Air supply control error, it's also description that if we have some error, we have reduction of efficiency in one side because fuel burned badly, it's not burned fuel, CO emissions, and on the other hand, it would be surplus air probably and would be reduced efficiency due to excessive air supply. All of them is asking, is it only on biomass that we deploy digitalization? In fact, no. In fact, you can run digitalization questions on every boiler. However, the question, the return on investment, what kind of problem are you solving online? It's my answer for all of them. So depending on the data, monthly data, we can just make a bad decision on efficiency. But if we run digital twin and we control optimum, our boiler operates at the maximum efficiency that is possible at that time, at the conditions of a boiler at that time. Okay. Biomass calorific value, it's also very interesting task, and we understand that biomass calorific value depend on the ash content, depend on the fuel content. It's described like a chemical formula C4H6 oxygen 5, probably, if I remember well now, and adding water and ash, and we have a calorific value of a fuel. But when we run equations at once, each 5 minutes we can evaluate what is the calorific value of a fuel and what is the oxygen content, water content of a fuel. And you can see variation of the fuel content over the time, starting from 40%, coming to 45, 40, 45, and so it's not stable. And because fuel water content is not stable, calorific value is not stable, and automation control system is controlling fuel amount also according to the commissioning engineer set points at the commissioning time perspective, and probably with some amount of fuel at that time when the commissioning engineer built the boiler automation and you run it, the boiler entering to operation. So and this effect cannot be, in fact, controlled by the control system. So what we are telling as boiler is operator assistance. In fact, in some countries, boilers are running without operators. In some countries, boilers are running with operators. Smaller boilers are running without operators. Higher capacity boilers are running probably with operators. And it depends on the country by country. However, it would be assistance for the human, for the efficiency control every minute, and keep boiler at maximum efficiency that is possible at that time, according to the situation of a boiler, according to when was previous maintenance activities done. You can forecast, predict maintenance, and store data. You can have historical data, not only one year, maybe a couple years. It's because data storage cost quite small. And in fact, if we are coming back from a technical perspective to the management point of perspective, so we should produce more heat with less fuel, change operation modes without losses, going from maximum demand to the minimum demand, from one fuel to another fuel, I mean water content, optimize maintenance decision and avoid human errors. Why beneficial for you would be digital twin with ISS boiler? Because operation quality depends on the person, or you are not happy with a boiler efficiency because of your control system operation. Your boiler efficiency is unstable. Later I would show some real examples with efficiency dependence on the amount of heat produced, and you would like to decrease maintenance costs. So if this is true, so you are beneficial from this solution. In timeline, we collect the data. If you already collected data to the cloud, and this data is, for example, in second-minute range, depending on parameters, sometimes we need minute range data, sometimes we need second range data. We collect data with to our cloud. We do inventory of your boiler system. I mean, all parameters, including fans, air supply, fans, flue gas, oxygen meter, furnace, heat exchanger, etc., etc. All components which describe a boiler. We make the digital model, digital twin, and you have operation. Usually, we ask for a 6 months. 6 months agreement, because data collection probably is less than 1 month. In a month, inventory and digital model probably it would be another couple of months. But operation, we run up a model, and we should check how model behavior, and you should feel happy to finalize project. So it's probably could be 6 months. Of course, you get data dashboard, you get reports of dashboards, and then reports about efficiency, about the cost of fuel consumption, and etc. and etc. So everything, all calculations done each 5 minutes. Later, this data processed to 1 hour data, or 1 day data, 1 week data, 1 month data, according to your needs. And you get reports, immediate notifications, and it's like a general instrument for the cloud solution. And who is a user of boiler system? If you have operator, of course, operator constantly review existing situation. If you have a head of a boiler house, he of course get reports and review data, analyze maintenance indexes, KPIs. And if you are a technical manager, you of course have your own role. So you motivate effectively working operators, you make a decision on the maintenance, and etc. and etc. So also fuel supply issues, fuel quality issues, also related, everything related to boiler. So if we make data-driven decisions, because we have data and data already involved to decision making, so you can reduce general human errors. If we are coming back to boiler efficiency, depending on the current situation, efficiency could be increased from couple percent to 10%. Digital operator increase personal productivity, and in fact reduce maintenance cost. Okay, current projects, 20 megawatt steam boiler wood chip. Data was collected through Energy Advice data collector software, as previously I showed diagram. And what was the target is fuel saving, increased lifetime, and control optimization. Findings prior to the project is high dispersion of fuel consumption and efficiency, bad accounting, in fact, accounting errors, or not bad account, probably bad accounting errors, and efficiency increase with higher heat load. It's in opposite. Efficiency should increase with lower loads, but not increase with higher loads. Heat demand, reason maintenance before heating, probably reason. way do maintenance and increase before heating season increase heat demand and increase efficiency probably, but not only. Bad boiler performance on minimum load we detected. Example is efficiency dependency on heat produced. You see 2018, 19, 20 data where heat production, monthly heat production amount is from 5,000 to 11,000 megawatt hours. And you see regression, that regression efficiency increase due to higher production. It's absolutely an opposite should be, but however it's a fact. However, when we run it digital twin, SAS boiler digital twin, we solved this, that the steam output it's 8 megawatt and efficiency 86, and steam output 10 megawatt, efficiency is 89%. So now it's right dependency efficiency on steam output, but not. In fact, it's an opposite. Project 30 megawatt steam boiler with 5 megawatt flue gas condenser, thermal oil consumer nearly 3 megawatt and 6 megawatt flue gas consumer. And data was collected with data collector software also. And project target is to understand minute range fuel consumption and efficiency. What is efficiency in each 5 minutes, and what is the energy fuel consumption in 5 minutes? After that is day and consumption, and then week, monthly consumption. And KPI is efficiency or fuel consumption. For example, output, what we delivered, it's flue gas flow metering. I described it earlier, example, where the flue gas flow meter installed showing 29 ton per hour, and we calculate 15 ton per hour, and everything is balanced, so it's just bad data. Burning process fluctuation identified, airflow meter correction, airflow meter installed. However, it's also have 10% error. Efficiency calculated, fuel consumption calculated, and silo level evaluated. We put the fuel to the silo, and we evaluate it's read. It's from the SCADA. It's control system monitor the silo level, and we monitor silo level. According to calculation, we know delivered fuel and we know burned fuel according to digital twin equations solution. So we monitor fuel, and it's trending quite well. So it is for the case studies. And what is the future trends? Industry has high automation level, in fact, but also this automation, in fact, do not cover today's needs, in fact. And business effectiveness requires creates some need of tools which help perform analysis and increase effectiveness. In fact, it's a business effectiveness in general. Industry already has big data. What is complication with this big data? But we have everywhere data, and we need to understand which data is related to one process. Is this data is important or not important data? And what we do, probably most common mistake, we add extra metering, which is extra cost, and put this metering data to the cloud and to the like a monitoring system. We have extra data and we have more big data than previously, and probably sometimes we don't need this metering device, but we added this extra metering device, so already have big data, but monitoring system only capable to collect and store data. And if a monitoring system only capable to collect and store data, this is not future. Monitoring system is not a future. It's a past. And existing system monitoring also capable to visualize KPI on a dashboard. Yeah, we can divide one number by another number if one number is measured value and another number is also measured value. But in the boiler system, we have complication. We don't have fuel calorific value. Probably fuel calorific value would be known only after, it depends on the situation, but only after probably 1-2 days, couple hours after fuel burned. And because of that, the data on the dashboard that the past was bad is not important. We don't need to understand that the past is bad, because we need to live now and we need to control and optimize now. KPIs by itself, visualization on dashboard, it stabilizes KPI. Yeah, of course, when we have fluctuation, we can assume and make decisions and impact, and we stabilize this impact, KPI. Due to human action, we need to make the action to stabilize. However, it's not enough. It's not enough to just stabilize KPIs, because when we have number efficiency, for example, boiler 87, is it good or bad? 87% at the maximum heat production probably is not very bad, but 87%, for example, at the minimum operation, it's not so good. This is not enough KPIs, just stabilize KPIs, and probably sometimes it's not possible to stabilize because KPI depends on the operation mode. And for example, in biomass boiler, we have examples when you burn fuel with a water content of 35%, and when you run boiler this January, due to winter conditions, water content in our application, we saw almost at the same time increased by 10%. Because suppliers of a biomass is supplying fuel from the same region, and climate weather conditions at this region are the same at that day, and biomass fuel qualities, water content is correlating in different furnace, and increase that water content, reduce that efficiency by a couple % and that's it. And you cannot do, in fact, nothing, just that situation. So in industrial application, human handmade optimization is not possible, because our systems, even in biomass boiler, is multi-variable system. What does it mean, multi-variable? It's on one hand, it's consumption dynamic. On another side is biomass calorific and water content dynamic. On another hand, it's control system, how to say, it's not like a mistakes, but also control system is some operation is optimized at one set point, but this set point is not optimal to another mode of operation. So we have multi-variable environment in general, and human, in fact, it's hard to do and to adapt everything each 5 minutes, for example, each hour. It's, in fact, it's impossible. So what is the future? All data connected to data pool. Your company probably already have many data from the accounting systems and etc. And probably you are collecting now, you are streaming to connect all data to the one pool, data pool. This data pool could be divided to the part. It could be one vendor, one database, it could be another database, third database, and etc. It could be separate database for a separate application, for example, accounting, SCADA data, smart meter data, and whatever. However, this data pool the future, I believe that the data analysis is performed fully automated way. When we have all data here, we just need to run digital twin for one process, optimize predictive maintenance, digital twin process for another process, optimization, predictive maintenance. So we run digital twins for different processes, for example, biomass boiler one, paper machine another, some kiln process another, and etc. So it's absolutely different. But all this data should be analyzed at automated way. No human impact on data analysis. And data analysis has only one target, is optimize, or in other words, for the financial directors, it would be save of a cost. How we see also that a company data analyst, your company could have data analysts, probably bigger companies already have data analysts which prepare code, for example, Python. For example, we have in a SaaS boiler Python, run Python code capabilities, and code, for example, run each 5 minutes or each 1 hour, each hour. And all this data is automatically used somewhere, for example, direct impact on the control system to optimize process. And data analyst expertise in different field could be limited. This would be a problem. If a data analyst of finance, it could be good in finance, but he would be bad in boiler. If a data analyst good in paper machine, probably he won't be good in another places. And access to the data analyst, like to the resource, it also would be limited because of in general, human is its limitation. Yeah, it's on one hand he do not know how to do, on the other hand he's very expensive if he knows what to do. And in fact, business model is that vendors like Energy Advice are providing function as a service. Even though we can found, for example, data pool or monitoring system, in fact, nearly free of charge, nearly, it's not, nothing is free of charge, but nearly free of charge. So data is here, but we need to run this data, and it would be like a function as a service. We come as Energy Advice, we connect to the data pool, we run digital twin, we provide you process optimization, we provide to you predictive maintenance insights like a functionality, and you don't change your existing monitoring system, you use your existing system, you use your existing control system, you don't need to change your control system. But we add extra functionality to your existing system, which collect data to the pool, which do process control, but we just put the process optimization like a set points, and we reach savings of the costs. So my presentation is almost done. We work, of course, we have some references. Not business cannot run without sales and real cases and success stories. So my presentation is finished, and you can ask question. You can type this question on chat, and I would be happy to answer these questions.